Hey everyone, thanks for joining. John here, software engineer with 10 years of experience, a PhD in economics where I studied post-secondary alternative credentials like coding boot camps and certifications. And I'm interested in helping you land your first or next programming role. To do that, the interview process is pretty important. And one of the major keys for big tech interview process is Leetcode. Latterly, Leetcode Kata. This is blog article 3. You can see the 3 up there. This will outline the Leetcode problems that I recommend you practice, including their order. And then article 7 will have some of the solutions. Today's focus will be longest substring without repeating characters, which should be the third, if I'm not mistaken. Let's check this out. 2-sum, 3-sum, longest substring without repeating characters. In addition to the blog article number 7 with solutions, there will also be this YouTube playlist. You can see it already has the Leetcode solution to word search. Check the comments of that video as well. The video itself is dated. If you want to pass the Leetcode submission, there are some comments that will include a short circuiting block that will make it more performant. And this will grow to include the entire kata. The extended kata is 20 problems. So there's a standard kata, which I think is 12, and there's an extended kata, which is 20 problems. Okay. Today, we are starting to build this out by focusing on longest substring without repeating characters. Before we get to that problem, which is the third problem, I would like to quickly do 2-sum and 3-sum. Okay, so that gives you the roadmap. 2-sum should be a 2 to 3 minute problem. It's an easy. 3-sum, if I remember the proper way to do it, is a 5-minute problem. And if I don't remember, if I have to backtrack, it could be 10 or 20 minutes. And I have no idea how long longest substring will take me. In theory, let's just glance at it quickly. I think it's a medium. Yeah. So in theory, it's not a very difficult problem. However, I haven't done it in a long time. Without further ado, I guess there's one other thing worth mentioning. You can sign up to Latterly for free. Latterly is completely open source. You can scroll to the footer and get the source code. Feel free to contribute if you'd like to. And you can join the Discord. Click the community tab, click the Discord button, and join the Discord. If I don't get to your question during the stream, you can bring it over to the Discord and chat 24/7. Speaking of 24/7 support, there is a AI chatbot. You can click that link for more information. Also free. And a new feature is the events calendar. So if you click this button, you will be able to add the Google Calendar for recurring events to your email calendar. Currently, there's Monday through Friday coding streams like the current one. And then there are evening streams, which are at 9 p.m. Eastern or 6 p.m. Pacific. And then there are small groups on Saturday. So come over to the Discord if you have an interest in joining those small groups. Those are not for everyone. You have to be a member of the community. That's one place where Latterly actually makes money. It's pretty much the only place. Okay. Now, without further ado, let's get into 2-sum. So I'll come over here. I will right-click, open link in new tab. It should take me right over there. I'll wipe out the existing solution. And let's quickly read through it. Given a one-indexed array of integers, so we're not using zero index, we want to find the index 1 and index 2 that will sum to the target given an array in non-decreasing order. Your solution must use only constant extra space. Tests are generated such that there is exactly one solution. So we don't need to worry about sad paths. There will not be a case with an empty output. And we can check these examples to confirm that. It's a single list. There's no empty outputs and there's no multiple solutions. Okay, so given that, in the worst case, I might need to check every index and numbers. But I shouldn't need to nest loops. So worst case, time complexity. it initially seems like O of n. I can simply use pointers. So space complexity seems constant. Okay. I'll initialize left to 0. Right will be the length of nums minus 1. So we're not using the one index for left and right, but we do want to use the right index for the return value, which means whenever I return foo, I will want to return left plus 1, right plus 1. So this is in our return case. Speaking of which, what is our return case? If we have a match, which means if the current sum is the target. Match found. Return one indexed indices. Okay. Else, if we don't have a target, the current could be over or under. So what if you are over target? We'll move a pointer. We'll do that momentarily. It'll pass for now. And then here we are under target. Move left pointer to increase sum. Okay. So here the left will be plus 1. Here the right will be minus 1. Because it's sorted, I can take the right pointer and move it to the left, and that will decrease my total sum. Okay. So the current sum here is numbers left plus numbers right. And let's just scan through it to make sure everything is correct. So I have left, that's good, right. As long as the left is less than the right, I can keep moving around. Once they've crossed, there won't be a solution anymore. But we're guaranteed not to need to address that situation. If it equals the target, we will return the one indexed. Okay. Else, if it's over, move my right to the left. Good. And it looks good to me. Let's go ahead and run it. Nums is not real. It's called numbers. That's my mistake. Let's see if I use nums anywhere else. Only in the one place. Great. Okay, so that took us a couple minutes. Thanks for the likes. Why do you do the same proofs every time I open this live? The reason we do the same problems is that Leetcode kata is a mastery and flow-based approach. So before going on to the next problem, you want to make sure that you've solved the previous problems and you drill them. You drill them by doing them over and over. So yes, I go through all of them every time up to the point where I'm doing one new one. And then, tomorrow I'll be doing 4 and then work my way up, ideally through the standard kata. And ideally, you're able to run through the entire 12 problems in a couple hours. You can totally get a job without being able to accomplish that goal, but that's the goal that I have in mind. And you can even go further to the extended kata. I have yet to do an entire pass through the extended kata, so I don't have a target time for that, but it would be more than 2 hours probably. Maybe you could get it done in 2 hours. Part of the practice is to state the context of the problem and write the pseudocode. So it's not just a matter of dumping out the solution. If you were trying to speed run the solutions without imagining a real interview in front of you, without walking through the complexity analysis, without writing the pseudocode, if you were just pure memorizing and speed running the solutions, you could totally do the 20 problems in 2 hours. Probably less than that. I like to have a controlled pace and imagine that I'm talking to a real interviewer. So for that reason, I'm not sure that you would get through the 20 in 2 hours, but you might. I haven't done it yet. Okay. And the second reason that we're going through these problems again is because I want to record the solutions and put them on this requested playlist. So the audience requested that I make a playlist of these solutions. So we're going back over them once again. Let's now go to threesome. And there is a meta flow between these problems so that one problem will often, although not always, help you solve the next problem. Oh, 3 is threesome closest. Maybe I'll be doing, because this is the expanded kata. I confused myself. So in the expanded kata, you go for threesome closest. But here in the standard kata, we'll go from threesome to longest substring. And the meta flow is that twosome will help us solve threesome, basically. All right, so let's solve threesome. Given an integer array nums, return all of the triplets. And here I have the ith index of nums and so on. So these are the values, not the indices. So we want to return a triplet of values such that I is not j, is not k, and so on. And they sum to 0. So there's a fixed target of 0 in this case. Notice the solution must not contain duplicate triplets. That makes sense. And we also notice the output here is an empty list in example 2. So we need to be prepared to handle the case where there are no solutions in nums. So let's look through some pseudocode. Initial approach is to wrap twosome in an O of n loop. This involves sorting nums. And I'll go ahead and nums.sort. This costs n log n time complexity, which is not binding. The overall time complexity initially seems O(n) squared. We can use pointers. So space complexity is constant. Okay. And we will call this a wrapper index of 0. You could also call it far left, or you could just call it left, and then your twosome left might be called middle. Or you could have two different lefts because technically they're in different scopes, but I find that counterintuitive. So I like to call this either wrapper index or even super left or far left. But we'll go with wrapper index for now. So I've initialized it here, and I will loop through all of nums. So while wrapper index is less than length nums, we will call twosome, and we will fast forward duplicates. Then we'll eventually return results. So let's define results. Results is a set over list for auto duplication. And we will place tuples within that set because a list is not hashable. But a tuple gets us what we want, and it is hashable. So let's go over here and we'll start to define twosome. We're on the class for solution here. So I do self nums. Then I'll also have the wrapper index and the results. But this doesn't tell me enough. I need the complement. The complement is equal to the opposite of the wrapper index of nums. That way, I'm guaranteed that the sum across the 3 will be 0. Does that make sense? So then I'll call self.twosome. Make sure this is in the same order that the arguments expect. Num wrapper index results complement. And here, let's assume that I've completed my twosome. Now I want to fast forward the duplicates. This means I will be increasing my wrapper index. Under what condition? Under 2 conditions. First of all, I need to not be out of bounds. The way that I can establish that is by repeating this same phrase. I don't want to increase the number if it's guaranteed to be out of bounds. That will give me an error. Okay, now that I'm guaranteed that +1 is within bounds, I can check the value. So the fast forward condition is value equality. If the complement is the same, I don't need to run toSum again. I already have the unique tuple. It's guaranteed to be unique. So if the complement is the same, that is my fast forward condition on wrapper index. Does that make sense? So if complement is equal to this expression, that's it. And what you might notice is that that is guaranteed to hit. It's guaranteed to hit once. And then we don't know if it may hit additional times. Exactly as intended. So I have no need for an external increment because this is guaranteed to hit at least the one case by construction. Thank you so much for the likes. Okay, so this looks pretty much correct. Now let's go implement toSum. So we need a left pointer. This is not going to be 0 now. We're looking at the slice to the right of the wrapper index. So left will be wrapper index +1, but right will still be the end of the array. We can't go further than that. In fact, it might need to be right -1. So here I'll write my while loop. While left is less than right, cursum is nums okay, so we have our current sum. And then we will compare the current sum to the target, or to the complement. The complement in this case is like our target previously. Did that make sense? So if current sum is equal to the complement, elif over, else cursum is under complement. Increase sum. And the way we increase the sum is by moving the left up. The way we decrease the sum is by moving the right down, just like we did previously. And the match case is going to be a little bit different because we want to fast forward. So we have a sorted tuple now, and we will do results.add sorted tuple. And then we will do some fast forwarding. Okay. The sorted tuple is the opposite of the complement. Why is it the opposite of the complement? Because my wrapper index is always further left of left. The opposite of the complement is the wrapper index of nums, deterministically every time. So I don't need to invoke a sort function. I can just write this. But notice that left here is an index, and we want the value. So it's the left index of nums and then the right index of nums. So this should be the sorted tuple, and you could even say sorted value tuple. Alfredo, long time. Good to see you. I'll get to your comment after I complete the problem. I want to get through this quickly if possible. It's good to see you, though. Okay, so here is the results. We've added it, and now let's fast forward. It's going to be analogous to what we did over here, but the literal will be different. So the analogy is that we're doing the same logical operation. Ensure that we're in bounds of the array, and then increment if the comparison value is equivalent. In this case, the comparison value will be left. You could pick right, either one of them, to perturb the left and right hands. You could pick either of them. I'll go for left. So cur left is the left of nums. We can just repeat this here. Don't repeat yourself, dry it up. And you can see we're basically caching the value. So the value under comparison is not the complement in this case, it's cur left. But do you see that we are doing the similar thing, is that we are going to fast forward left, as long as the left index of nums is equal to the cached cur left. So I might have an array which says 0, 0, 0, 1, 1, 1. I want to skip over those zeros and those ones. So that's what we're doing here. It's going to save us a bunch of compute time. Thanks for the follow. Thank you for the likes. Okay, here the wrapper index is not correct. The boundary condition is left under right. So it's similar. It's two expressions. It's a boundary check and an equivalence check, but the literals in those checks have been altered in the context of the two-sum. So I think this is right. At this point, let's give it a go. So the current index, list index, is out of range. Let me do this -1. Yeah, that was our problem. And great. Let's see if that succeeds over here. Awesome. Okay, so I don't know exactly how long that was. I think that was maybe 10 minutes-ish. I'll go back and time it later. But there you go. That's a pretty quick run through three-sum. All right, let me get to your comment, and then we will move on to longest substring next. So Alfredo says, hey, I did this question on my interview with Amazon Friday. Sadly, I failed, but the twist was that repeating customers were allowed. Could you go over it when you can? That's interesting. How is a customer defined? Is it just a string which identifies a customer? So the problem is longest substring without repeating characters. So I guess there might be a list of customer names, like my name is John. So maybe you cannot repeat characters, except you can repeat JOHN. And so you would need to have a cache there, basically. You would need to have a cache and a smaller window and a list of these names and check it across that. One of the runtime trade-offs there would be if you use a list and you loop over the list, that's O of n. And so you might want to turn that into a map. And so if you listify that map, then I could just say if John is in, and that would improve the performance of that subroutine, which may or may not impact the overall routine. Repeated characters, sorry, not customer. Okay. So longest substring with repeated characters, you're saying. So that's just the longest substring, which is just the length of the whole string. The longest substring of a string will always be the string itself. So I wonder if, I wonder if one of two things is going on. First of all, you might be remembering the description of the problem or either remembering it incorrectly or communicating it incorrectly. That could be one thing. The other thing is when you say they allow repeated characters, maybe you have a fixed list of characters which can be repeated as opposed to repetition of any character. If you're allowed to repeat any character, the longest substring will always be the string itself. If you are only allowed to repeat selected characters, then it becomes sort of like a filter problem. Anyway, that would be an interesting problem to do, but it's not the problem at hand. Feel free to come over to the Discord and write a paragraph. And I will do like a custom Leetcode problem for you if you want in a different stream. That could be quite fun, user-submitted Leetcodes. But for now, let's continue on the kata, and we will be dealing with longest substring without repeating characters. Whenever I open this, I think it's going to have my solution from months or years ago, the last time I did it. So the first move that I'm going to make is just to wipe out the solution before I read it. Okay. Good solution. Good explanation. Okay, great. So if I flop on this, I'll go check that out. Will do. Thank you. Thanks, Alfredo. Good to see you. Oh, my drink is gone. Bummer. So let's start by reading. Given S, find the length of the longest substring without repeating characters. Really short description. I love it. We'll look at a few examples. Here, the output is 3, so they want an integer return, basically. 1, 3. I'm wondering if I could have an output of 0. Right, so constraints 0 is less than or equal to s.length. So it could be the case if it's 0 or 1, then I can immediately return. So we'll take care of those edge cases and proceed from there. Intuitively, I might need to look at every string of the character because the entire string might be non-repeating. In the worst case, whole string is non-repeating. So best possible time complexity appears at O of n. Best case space complexity is constant. I may end up using a hash or like a hash set, hash map to cache characters. And I may cache a substring that grows, or like and I may cache a sliding window basically. And I may cache a sub window of max size ON. So worst case space complexity seems ON. To do final space complexity. So basically, I have a target time complexity in mind, and I have 2 possible space complexities. And at the end, I'll go back and say, okay, that was the one. But we can see that I have a range in mind, and I think that's enough to get started. Another interesting question here is, do I want to sort? That's just like a generic, besides checking for edge cases and then checking for recursion, checking for sort is another basic thing that's really interesting to think about. Here, sorting can give us some idea of the boundary of the length of the max substring, but it won't solve the problem because the order is critical. The order is critical. So I'm going to skip sorting for now. All right, so here I will say cur longest substring equals 0. And then we'll eventually return cur longest substring. Handle edge cases at ling 0 or 1. So if length s is 1, I don't actually need an else. I can just use the or. Okay. So if length s is 0 or length s is 1, we'll just return length s. Okay. So now we have length s is guaranteed to be greater than 1. And I'll say while, let me do a, use a pointer. And do I just want to have a left to right pointer? I think I want to define an entire window. Let's define a subwindow with left and right. So this will be a sliding window is the idea I'm going for. Considering like implementation is a sliding window inside of this while loop. Yeah, that's all Python. Yep, this is Python right here. So left is going to be 0 initially, and right is going to be also 0 initially. And we will say while left is less than length s. What's the pitfall here? The pitfall here might be nothing. The pitfall, there's two pitfalls here. One, if right goes beyond the boundary, I could get an out of bounds error. I think we can handle that inside the loop. The other pitfall is that left may not need to go all the way to length s, so I need to have some early exit logic, but I think we can do both of these. Early exit condition. Ensure right doesn't go out of bounds, boundary. Out of bounds is fine. Okay. We can even say while left is less than length s and right. There, solved one of my to-dos. I might want to change that though, because I might want to have right go all the way to the end and then toggle L. So we'll deal with that later. This works for now. Okay, so while I am in this range, what do I want to do? I want to move right first of all, and then move left if I have to. So I want to grow right as far as possible because I'm starting at the far left and I'm trying to seek this goal of getting the whole thing. That would be my maximum possible. Lead with right, move left only if needed, and by the minimum distance needed in order to maximize range from L to R, from left to right. And so current longest substring will be a maximum of that. Okay, so distance is right minus left. Cur longest substring is max of cur longest substring or distance. We can even call this cur distance. So this will go down at the end. The first thing that I want to do, actually this will go at the top. This will go at the top. Why do we do it at the top? Because when I increment right, I want it to do the while checks before I register it as a proper value. Because what I could do here is say right plus equals 1, and it might overflow the boundary and then register that as a new distance before it exits the loop, which would be an invalidly large solution. Does that make sense? Kelvin Parker, thanks for being here. All right. So I'm going to start with this, and then we will iterate after. And I don't know that I need an early exit condition anymore. I don't know that I need that anymore. There is a way that I could have an early exit condition. Skip early exit condition for now. Like, here's the condition, early exit condition. If cur longest substring can never exceed early exit condition. If cur longest substring can never exceed, if cur distance can never exceed cur longest substring, then we can exit early. Let's skip this logic for now to preserve time for implementation time and syntax brevity. So we'll skip that for now, but that could be a thing that we add later. And if we get a timeout, if Leetcode is like, you're too slow, we'll come back and implement that. Where are you from? Originally Austin, but I'm living near Washington, D.C. these days. How about you? Okay, so now let's go on to the lead with right, move left only if needed, and by the minimum distance needed. So let's start by leading with right. So right plus equals 1. And now, I want to do that length check anyway, because I could be out of bounds right now. So if right is equal to the length of S, we'll go ahead and break. I am from UK, London. Awesome. Thanks for being here. All right, now we're guaranteed not to be out of bounds. So now that we're guaranteed not to be out of bounds, what is my new character? Sam, you should be taking a nap. Kid woke up from nap. Fun stuff. I might have to end early. We'll see. Okay, for now, let's keep trying. So the new character will be this one. And how do I know if I need to move left? If need to move left. Left equals new location. It's not just a matter of incrementing left, actually. I might need to move left many points. I might need to move left all the way up to right in the worst case. Move left to right in the worst case. In fact, what I can go ahead and do is just move left up to right and then have a negative while loop where it goes back until it hits a repeating character. Left equals right. Backtrack on left until I hit the repeater. Okay. So new left character is going to be S left. So while new left character is not in word set. I think I want to set here. So we have a cur word set. Left minus equals 1. Let's say while left is greater than 0. No, it could be 0. While it's greater than -1 and. Okay, so we make sure that it's in boundary, and then we check it for our change condition. So here's the cur word set. All right. Whenever we have the new character, we can add it to our cur word set. So this means, what if in the worst case, I'll have 2 adjacent duplicate letters? SS, AA, BB. So I check B. I move forward. I found a duplicate. So I need to move left. So then I reset B to the same second. I reset left to the same second B, and I consider moving back to the left, and I can't even backtrack 1. So I just stick with left here, and then right will try to continue, and right will say that's the end, and we'll exit. So I think this is a fine way to do it. Let me make sure that I replace my pseudocode. So need to move left is a pseudocode. How do I know that I need to move left? Let's call it should move left. That's more idiomatic. It's a better variable name. So should move left will happen when new character is already in the set. So by default, it will be false. If foo, it becomes true. Okay. And that condition, once again, is that new char is in. We can just say in. New char in cur word set. So if it's in the set, then I need to move left. Okay. And if I move left, we are wiping the whole collection. We are wiping the whole collection. And we will add the current letter only. So this will be reset collection at right index char. Okay, so we reset the collection at the right index char. Both hands are now pointing at the second B in the case of BB. Does that make sense? And now we will try to rewind the left. Initializing it this way is problematic. It will always hit the current letter. Maybe I can overcome that by skipping this line. I'll consider doing that. So we need to be adding these letters as well. We need to be adding these letters as well. So new left char will be added to the current word set. So we repoint at the second B, and then we're looking left, 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 left. Cool. This seems intuitive, so let's submit it and see how wrong it is. Left is greater than -1 is an invalid syntax. Okay. Is not in. Yeah, that's not right. So is it just not in? So the output is wrong. All right. Let me make sure that I'm capturing this distance here as well. So where's the distance computed? Current longest distance is maxed up there. I want to also compute it under the rewind step. Okay. So we'll also compute it under the rewind step. Maybe that's all that I need to do. Let's try that. Nope. Okay, so that's going to be our time box. Thought I had an interesting solution, but it doesn't seem to work. So let's look at the actual solution. Oh, I had a link to a good explanation here. Let's open this up. We use a dictionary to store the character as the key. The last appear index has been so far as value. So it's a dictionary approach. Do you have Discord? Yes, I do. Latterly.io. Discord is under the community dropdown. So this is quite a different approach. For R in range length S, still looping through the whole string. If it's not in scene, we can keep increasing the window. So there's a left and a right. So it is still a sliding window approach. That's good. Time complexity ON, space complexity OM. The number of unique characters of the input. That would just be ON because in the worst case, they're equal. Every character is unique in the worst case. Let me even reevaluate my own. So this approach that I took when I cached, and I have this cur word set, that would make it ON space complexity. So the time complexity and the space complexity are correct, it seems. All right. The dictionary instead of the set is what's very different here. So me, I'm keeping a list of all the characters that I've used. And I simply expire it when I run into a duplicate character. In this case, it seems to be like a 4-pointer approach. Is that right? So you have the left and the right. Here's the right. You have the left and the right maintaining a window. And where's the cur? SR is the current character. If the current character is not in scene, then it takes the max of output. So this bit is similar. The current distance is over here. You subtract the left from right. Oh, and you add 1. Okay, that can explain why I was off by 1. But in the test case, I think I was off by 2, eh? So why would I have been off by 2? Let me go ahead and adjust my code anyway. Right minus left plus 1. Let's keep understanding this solution, and then I might just do some test cases of my own. So if the current character is not seen, we keep increasing the window by moving the right pointer. Good, that's the same thing I'm doing. If it's not in scene. But what if it is in scene? If it is in scene, I say we should move left. And I reset my left to my right, and I rewind on left. What they do is they say there are 2 cases where the current string is seen. In the first case, it's in the window, and in the second case, it's not in the current window. That's true. That's true. Ah, okay. So theirs will be faster, actually, because they do not rewind, like reset and recompute. That could be happening many times, potentially. They just know because they've stored ahead of time. And the difference in memory is trivial. So mine is taking O of n memory anyway. Theirs is arguably taking O2n. Not even, because they're just dealing with pointers beyond scene. So it's not even O2N. It's like equivalent memory. All right, well, I think this wraps it up for today, and I will adjust my mental model and try this again. So the mental model difference is that when I need to alter the left hand, I should not reset to current and rewind left. I should simply know ahead of time for every letter, if I see it, where did I see it? If I see it, where did I see it? I should already know that. So the error in my set approach is that I was indicating binary. I was indicating that I've seen or not seen a character. I was not indicating cardinality. I was not indicating where have I seen it. So I couldn't snap there. I have to recalculate there, which is less efficient. Great. The good news is that even though I messed it up, I can clearly see how I messed it up, and we'll give it another go next time. Thanks for being here. Sharp Dev Trev says, I forgot, where can we share our off-brand solutions to Leetcodes? Never mind, found it and sent my awkward but effective solution to Threesome. Thank you so much, Trev. Yeah, so you said you already found it, but for the rest of the audience, I'll remind you, if you go to Leetcode Solutions, you can come over here, and it says, if you have more solutions, feel free to submit them here.